this video we're going to be looking at our second method for solving systems of equations, and that is the elimination method. Basically our goal here is going to be to eliminate one of the variables so that we can very easily solve a one variable equation to find that missing value. So if we take a look at our first system here, we have two equations, and the first thing I notice when I look at these is that I have a negative 4x here and a 4x here. These coefficients are opposites, and I know by the additive inverse property that when I add opposites, I'm going to get 0. And that will eliminate the x terms, and I'll just be left with y on one side and constants on the other. So that creates a relatively simple equation for me to solve. So since they are opposites, what I'm going to do is actually add these two whole equations together. So we have negative 4x plus 4x is 0x. I'm going to be careful with the signs here. So we have negative 5y plus negative 7y. So we have negative 12y. And then on the other side of the equal sign, 11 plus negative 23 is negative 12. Now the 0x, I don't need to worry about this anymore. I divide both sides by negative 12, and I get y equals 1. But of course we're not finished because we have to solve for x. We want to make sure that we get the full solution here. So now I can pick either one of my equations and substitute in my value for y. Once I do that, I'm again left with an equation in one variable that I can very easily solve. So if we come to our first equation, doesn't matter which one you use, but I'm going to use the first one here. We have negative 4 times 1. We're plugging in for y. So we're going to have negative 4x minus 5 times 1 equals 11. You want to make sure you substitute into the right spot or else you're not going to get the right solution. So we have negative 4x minus 5 equals 11. And now we just go through and solve this equation for x. So negative 4x equals 16, which gives us an x value of negative 4. And remember, for our solution, we're always going to write this as an ordered pair, x comma y. So we'll have negative 4, 1. Since we got a solution, this is a consistent system. And since we just have one solution, this is an independent system. Go ahead and pause the video and see if you can solve the second system here. Alright, so if you look at this system, again we have two coefficients that are very close. In fact, in this case, they're actually equal. So instead of adding, because that's not going to get rid of a term, I'm actually going to subtract here, because I know that 5x minus 5x will give me 0. This was supposed to be an equal sign here, not a plus sign, so just make sure we have that change. When I subtract, 7y minus 10y is negative 3y. 0 minus 0 is still 0, so we end up with a y value of 0. Then again, I can substitute this into either equation in the place of y. We end up with 5x equals 0, regardless of which equation we actually substitute that into, which gives me my x value of 0 for a solution of 0, 0. Again, since we have a solution, this is a consistent system, and since we just have one, it is independent. Now, if we take a look at this system, when we look at our first term, I have negative x and positive x, so I know that when I add, those are going to eliminate. So we want to use addition here. So we have 0x, and then negative 5y plus 5y, those are actually going to cancel each other out as well. So we have 0y, and then negative 15 plus 6 is negative 9. So really what I get down to is 0 equals negative 9. But we know that that's not going to be true. This is our contradiction. So this is where we have no solution. So if we come down, we can put no solution here, or NS if you want. And since we don't have a solution, this is an inconsistent system, and we can't say it's independent or dependent, so we don't have to circle anything there. If we look at the second system on this page, these aren't nicely organized for us yet, so we have to actually rearrange the terms so that the x's line up vertically, the y's line up vertically, and the constants line up before we can do any sort of eliminating. So my first equation looks good. I just need to rewrite my second equation. So we have negative x plus 10y equals negative 4. And now if we slide this x term over, we have positive x minus 10y equals 4. So now we can go ahead and use our elimination. If I look at the first terms, I have negative x and positive x. So when I add those, they'll eliminate, so we're going to use addition. So we have 0x, and then 10y plus negative 10y is 0y. And then negative 4 plus positive 4 is 0. So in this one, we end up with 0 equals 0. No, we know that that's always going to be true. So this means that our solution is infinitely many solutions, or we have an infinite number of solutions. Remember here, we can also use IMS, but we cannot use all real numbers. Since we have at least one solution, this is a consistent system, and it's IMS, so that is a dependent system. Now, sometimes we're going to be given systems where we can't just multiply, or where we can't just add or subtract the terms to eliminate something. If we look at this system, I don't have any coefficients that are equal or that are opposites. So we have to do a little bit of work first. Your first step is to decide whether you want to eliminate x's or y's. Some people always like to do x, some people always like to do y. It doesn't really matter, just as long as you make the choice. So if I decide that for this one, I'm going to go for the x's. So in order to get my x's to match up, here I have 3x, and here I have negative x. In order to eliminate that, I need to make this negative 3x or positive 3x. But to get negative 3x, we're going to multiply this whole equation by 3. So when we do that, we'll have negative 3x plus 9y equals 30. It's very important that you multiply every single term by 3. Otherwise, we're not maintaining that balance across our equal sign, and the form of the equation will change. We bring our other equation over, so we have 3x minus y equals 2. And now since we have opposite coefficients, we can go ahead and add. So negative 3x plus 3x is 0x. 9y plus negative y is positive 8y. And 30 plus 2 is 32. And we can see that y is going to be equal to 4. Now I can go ahead and substitute that into either of my original equations to solve for x. So if we use the first equation, we're going to have negative x plus 3 times y, or 4 in this case, is equal to 10. So negative x plus 12 equals 10. We end up with negative x equals negative 2, so x must be 2. Then, as always, we're going to go ahead and write our solution as an ordered pair. So we have the point 2, 4, and this is a consistent, independent system. Go ahead and try the second system, see if you can solve for x and y. Alright, this system is a little trickier because one of the coefficients is not a direct multiple of the other. So I actually have to multiply twice here. And again, you can decide whether you want to eliminate x's or y's. In this case, I again decided to go with x's. If you eliminated y's, that's completely fine. A lot of times when we work with systems of equations, there's going to be more than one right way to find the solution, and that's okay. It's not going to be wrong if you didn't do it exactly the same way that I did. So in this case, if I want to eliminate x's, I need to get a common coefficient. So we have 3 and negative 2. Now I either need to get these to be exactly the same or opposites of one another. So if I multiply this one by 2, we get 6x. And if I multiply the bottom equation by 3, we get negative 6x. So I know that when I add those, I'm going to get this 0x, and the x term will be eliminated. So I go ahead, I do that, I get y equals 1, and then the process is exactly the same as it was before. We substitute that value in and solve for the x coordinate. So my final solution is negative 2, 1, and this is a consistent and an independent system. Okay, go ahead, pause the video, and see if you can solve the first system on the left. Alright, in this system, again we have to multiply twice, so I decided to eliminate the x's. I'm going to just multiply, find the common multiple of 3 and 4, which is 12. So we multiply by 4 up top to get negative 12x, by 3 down below to get positive 12x. Those are opposites, so we're going to add to eliminate the x term. And then it also ends up eliminating our y term, but on the right-hand side of the equal sign we have 4, which leads us to the statement 0 equals 4. This is a contradiction. So this is our no solution, which gives us an inconsistent system. And again, it's neither independent nor dependent.